Hello everyone, today we're doing a worksheet on travel graphs. This is question number 1, which simply says, the diagram shows a speed time graph for the journey of a car. Calculate the total distance traveled. So all we have to do is find area under the graph. Total distance traveled in a speed time graph is simply the area under the graph. So the first thing you need to observe is that is there a unit conflict in the x-axis and y-axis? No, there's not, because the x-axis is meters per seconds and the y-axis is in meters per second and x-axis is in seconds as well. So we don't need to worry about the units. So we'll simply find area under the graph. This shape is a trapezium. So area of a trapezium is half times height times sum of parallel sides. So the height here is 12.5 and the sum of parallel sides are, this lower side is 280. So 280 plus the upper side is 20 minus 200. So that's just 220 minus 20, sorry. So that's simply 200. Find this product and you will get 3000 meters. Okay, the next question is, the speed time graph shows the first 50 seconds of a journey. Calculate the acceleration during the first 15 seconds. Acceleration is the slope simply. So the slope of first 15 seconds would be rise over run, which is 25 over 15. Again, before we do this, what I forgot to do was to check whether there's a unit conflict. No. Speed is also in meters per seconds and time is also in seconds. So we're good to go. 25 divided by 5 will give you the answer. What do we get? 25 divided by 15, we get 1.66666. So rounded off to 3 significant figure is 1.67. It's the speed, so meter acceleration, so meters per second square. Part B, the distance traveled in the first 50 seconds. So we have to find area till the first 50 seconds. So that's a trapezium. So we'll find area of the trapezium, half times height, which is 25, times sum of parallel sides. This lower side is 50 and this upper side is 50 minus 15, which is 35. So plus 35, which will give us the answer. Let's see, 0.5 times 25 times 50 plus 35, which gives us 1062.5. This was the distance, so meters. Okay, question number 3, which says the diagram shows the speed time graph of a car. It travels at 28 meters per second for 20 seconds. We can see that from the figure. So it's traveling at 28 meters per second for the first 20 seconds and then it decelerates. The following slope is showing deceleration until it stops after a further 10 seconds. Calculate the deceleration of the car. Deceleration is simply the slope, this slope. So let's find the value of this slope. It's going to be rise over run, but again, before I do so, I need to check for any unit conflict, which there are none, because this is also in meters per seconds and this is also in seconds. So we're good to go. Let's find rise over run. So the rise is 28 and the run is 10 seconds, which gives us 2.8. The unit would be meters per second square since this is deceleration. Then calculate the distance traveled during the 30 seconds. So the distance is simply area under the curve, so area under the graph. So this shape is a trapezium. So area of the trapezium is half times height, which is 28, times sum of parallel sides, which is 30 plus 20. So find this product, half times 28 times 50, which is giving us 700, which is the answer. The unit is meters. Okay, next question. An animal starts from rest and accelerates to its top speed in 7 seconds. So we can see in 7 seconds it accelerates to its top speed, and it continues at this speed for another 9 seconds. So for another 9 seconds it's continuing at 14 meters per second, and then it slows to a stop in a further 4 seconds. So within the next 4 seconds it is stopping. Okay, the graph shows this information. Calculated acceleration during the first 7 seconds. So acceleration during the first 7 seconds is simply the rise over run here. So rise is 14 and run is 7. So the answer is 2 meters per second square. Part B, write down its speed 18 seconds after the start. So 18 seconds after the start is here, and the speed is this value. All you need to do is read out this value from the graph. So it looks like around 7 to me, and in the marking scheme you're allowed to write anything between 6.7 to 7.3. So 7 is a good enough answer, meters per second. Part C, calculate the total distance that the animal travels. So that's simply the area under the graph, so which is the shape of this is a trapezium. So half times height is 14 times sum of parallel sides. The lower side is 20. The upper side is from 7. This is 7 till 16. So that makes this is 16. So between 6, 7, 8, 9. So this should be 9 units. So let's say 0.5 times 14 times 29, which gives us 203 meters, which is the answer. Again, the first thing I should have done in this question is checked for any unit conflicts, which there are none. Otherwise, we need to do some adjustment before we can start doing the questions, as we'll see in the later questions. Okay, question number 3, which says, question number 5. The diagram shows the speed time graph for the last 18 seconds of Roman cycle's journey. Calculate the deceleration. Deceleration is represented by the falling line, and deceleration is the slope of the falling line. So for part A, we simply have to find slope of the yellow line, which is rise over run. Run is 10 till 18, so 8 units. So the answer is 0.625 units is meters per second square. Units are meters per second square. Part B, calculate the total distance Roman travels during the 18 seconds. Total distance is found by area under the graph. So this shape is made from multiple compound shapes. So I will break it into one trapezium at the left, then one trapezium at the right. So I see 2 trapeziums. So I'll use the area of these 2 trapezium. Area of the orange trapezium is half times height. Wait, this is not a trapezium. Why am I calling it a trapezium? Trapezium has 4 sides. This actually has 5 sides. So I can actually break this into a rectangle, a triangle at the right. This is a triangle. And then a trapezium at the top. This trapezium. This trapezium. And then a rectangle at the bottom, this rectangle. So I'll have to find 3 areas to get to the distance covered, total distance covered. So let's start with the green green trapezium. Half times height. Height is from 1 till 5, which is 4 units time sum of parallel side. One side is 10 units. So this is 10 plus the upper side is from 4 till 10, which is 6 units. Then area of the yellow rectangle, which will be length times width, and then area of the triangle, which will be half times base times height. So let's see, what do we get? 0.5 times 4 times 16 plus 10 times 0.5 times 18 times 5. Oh, I've just made a huge mistake. This length here is not 18. It's 8. So 18 is wrong. Sorry about that. It's 8 because the base of the triangle is 8 units. It starts from 10, it ends at 18. So that's 8. This product will now give me answer 62 meters. Okay, the next question is, the diagram shows the speed time graph for the first 120 seconds of a car journey. Calculate the acceleration of the car during the first 25 seconds. So acceleration would simply be rise over run of this line. So for part A, the rise is, first check if there's a unit conflict, no. So rise is 20, run is 25. So the answer is 0.8. 20 divided by 25 is 0.8. And the unit is meters per second square. Part B, calculate the distance traveled by the car in the first 120 seconds. So we'll have to divide it into further shapes. So this is a triangle. Then we have a rectangle. This is a rectangle. Then we have a trapezium. And then we have another rectangle. So find areas of all these compound shapes and then add them. And in the end we have a rectangle. So let's start with area of the triangle. That would be half times base, which is 25, times height, which is 20. Then we have a rectangle, length times width. So the length is 20 units times the width is from 25 till 55. So that's going to be 30 units. So we have length 30 over here. So this is 30. So times 30, and then area of the trapezium, which is going to be half times height. Height is the length connecting the two parallel sides, so this is 10 units, times sum of parallel sides, so this length is 20 units, plus this length is 15 units. Plus area of another rectangle, so the height is 15 plus the width is 65 to 120, so 120 minus 65, which is 55. Let's find this product, which gives 1850 meters. Okay, next question. The diagram shows the speed time graph for the last 35 seconds of a car journey. Find the deceleration of the car as it comes to stop, which means this line. So we need to find the slope of this line. So the rise is 15, the run is 5. So answer is 3 meters per second square. Part B, calculate the total distance traveled by the car in the 35 seconds. So that's the area under the curve. So let's break it into subparts. This is one rectangle, then a trapezium, and then another trapezium. Okay, so start with area of the red rectangle, that's length times width. So length is 25 units times width is 10 units plus area of a trapezium, which is half, times height is again the length connecting the size of the length connecting the two parallel sides, so that's simply 10 units, times 10 times sum of parallel sides, so the red line is 25 units, the purple line is 15 units, plus area of the final trapezium, which will be half, times now height is this vertical height, the line connecting the two parallel sides, that is 15, times sum of parallel sides, so this length is from 20 till 30, so that's 10 units, and this length is from 20 to 35, which is 15 units. So 10 plus 15. Find this product and that would be your answer. And the answer is 637.5 meters. Okay, the next question. The diagram shows the speed time graph for 70 seconds of a car journey. Calculate the deceleration of the car during the first 20 seconds. So we need the slope of this line. So the rise of this line is 6 units, part A. Check for the unit conflict first. There's none because speed is in meters per second and time is in seconds as well. So rise is 6 units upon run is 20 units. So rise over run 6 upon 20, which gives 0.3 meters per second square. Okay. Next we have to calculate the total distance traveled by the car during the 70 seconds. So that's going to be area under this graph. Let's break it down into area of a trapezium and then area of a rectangle. So let's find these two areas, add them and get the answer. The first area will be half times height. Height would be this. It's from 0 till 20. So height is 20 times sum of parallel side. This side is 16 and the other parallel side is 10 units. And then plus area of the other rectangle, which would be length times width. The length is 10 units, the width is, this is 10, and the width is 70 minus 20, which is 50. Find this product, which would be the answer, which should be 760 meters. Okay, in the next question, the graph shows 40 seconds of a car's journey. The car traveled at a constant speed of 20 meters per second, decelerates to 8 meters per second, and then accelerated back to 20 meters per second. Calculate the deceleration of the car. Deceleration is represented by the falling line. Deceleration is found by finding the slope of this line. So I don't see any unit conflicts in speed and time. Both are per seconds. So we can directly find the rise over run. Rise is from 8 till 20, that is 12 units, and run is from 10 till 15, so 5 units. So the answer would be 12 upon 5, which is 2.4 meters per second square. Part B, find the total distance traveled by the car during the 40 seconds. That means we have to find area under the curve. So I'll break it into sub figures. So a rectangle, I can find area of this rectangle. That would be length times width, so 10 times 20. Then I can find area of this trapezium, which is half times height times sum of parallel sides. So plus half times what is the height? Height is from 10 till 15. So 15 times sum of parallel sides. So the parallel side one is 20 units and the other one is till 8. So 8 units. Then area of another trapezium. Here it is. So area of this. Okay, this is going to be half times height is from 15 units till 30. So that's 15 times sum of parallel side. This side is 8 units and this side is 20 units. So 8 plus 20. And then the final rectangle, which is this. So this would be 20 times 10. So find this product, the final answer, and that should be 680 meters. All these sums and products in the calculator should give 680 meters. Okay, I've made a mistake. This length here is, the height of this trapezium is 5 units. I wrote 15. So this should be 5, and then we'll get the answer 280, which is the answer in the marking scheme. Okay, in this question we actually have to draw a speed time graph. So let's read the data. A car passes through a checkpoint at time t is equals to 0 seconds, traveling at 8 meters per second. So at time 0, the speed is 8. It travels at this speed for 10 seconds. So we make a straight line till 10 seconds. The car then decelerates at a constant rate until it stops at 55. So here's 55 and we show a constant deceleration. So this is the speed time graph. Calculate the total distance traveled by the car after passing through the checkpoint. So that's just going to be area under the graph, which is a trapezium. So half times height times sum of parallel side, 10 plus 55. This should give 260, which is the answer. The next question. Emily cycles along a path for 2 minutes. She starts from rest and accelerates at a constant rate until she reaches a speed of 5 meters per second. So she starts from rest and accelerates at a constant speed of 5 meters per second. She starts from rest and accelerates at a constant rate until she reaches a speed of 5 meters per second after 40 seconds. So at 40 seconds she reaches 5 meters per second. So this is the acceleration. She continues cycling at 5 meters per second for 60 seconds. So we go 60 seconds beyond this, 10, 20, 30, 40, 50, 60. Here you go till 100. And then she decelerates at a constant rate until she stops after a further 20 seconds. So here she is decelerating and then she stops after a further 20 seconds. So we're done making the graph. Part A is done. Part B, find Emily's acceleration. So the acceleration will simply be the rise over run of this. So that's going to be 5 upon 40, which will give, you can just leave the answer like this for part B. Sorry, this was part B, not A. Part B is 5 upon 40. Okay. Part C, calculate Emily's average speed for the journey. So average speed is total distance upon total time. So total distance would be found using area under the graph, and total time is 120 seconds. 120 seconds, and total distance is half times height is 5 times sum of parallel side is 150 plus 40 till 100, which is 60. So this should give 3.75 meters per second, the average speed of the journey. The next question. Petra begins a journey in her car. She accelerates from rest at a constant rate of 0.4 meters per second square for 30 seconds. So we have the acceleration, we have the time as well. So acceleration is actually the slope, and slope is rise over run. So acceleration is 0.4, rise I don't know, the run is 30. So 0.4 times 30 is 12. So rise is 12 and the run is 30. So rise is 12 units rise, run is 30, which means this first line here is telling us to make a straight line from here till here. This line will have a slope of 0.4. So again, a line from here till 30, 12. This is representing an acceleration of 0.4. She then travels at a constant speed for 40 seconds. So now she maintains the speed for 40 seconds. 10, 20, 30, 40. Here we go. On the grid, draw the speed time graph for the 70 seconds of Petra's journey. Done. Next question. The diagram shows the speed time graph for the first t seconds of a car's journey. Find the acceleration during the first 10 seconds. Acceleration is the rise over run, which is the slope. It is simply 12 rise and run is 10. So 1.2 meters per second square. This is part A. Part B. The total distance traveled during the t seconds is 480 meters. Find the value of t. So we have the area under the graph. Area under the graph is 480 meters. And what's the formula for area of trapezium? Half times height times sum of parallel sides. This side is t and this side is t minus 10. So add these, t plus t minus 10. So we're getting 480 times 2 divided by 12 is equals to 2t minus 10. And then we get 480 times 2 divided by 12 gives 80. 80 plus 1 is 90. 90 is equals to 2t. So t is equals to 45 seconds. Okay, next question. The diagram shows the speed time graph for a car traveling along a road for t seconds. To begin with, the car acceleration is 0.75. Acceleration is the slope, which means the slope of this line is 0.75, and in part 1 we have to find the value of v. So slope is rise upon run. This is part 1. Slope is 0.75, which is the acceleration. Rise is v, run is 20. So solve this and get the value of v, which will come out to be 15. Okay, part 2. The total distance traveled is 1.8 kilometers. Since the speed is in meters per second, change this into meters. So 1.8 times 1000 is 1800. So for part B, we do 1800 equals area under the curve, area under the graph, and then which is a trapezium. So half times height is v, which is 15, times sum of parallel sides, which is till t, plus this upper length is 110 minus 20, which is 90. So t plus 90. Solve this to get the value of t. So I'll do 1800 times 2 divided by 15 minus 90, which is giving me 150. So t is equals to 150 seconds. The next question. A car starts from rest and accelerates from u seconds until it reaches a speed of 10 meters per second. The car then travels at 10 meters per second for 2u seconds. The diagram shows the speed time graph for the journey. The distance traveled by the car in the first 3u seconds is 125. So we will build our working on this. Part A, we need to find the value of u. So 125 equals half, equals area under this graph, which is a trapezium. So half times height into sum of parallel sides. Half times height is 10 times sum of parallel side. The lower parallel side is u, the upper parallel side is 2u. This side would be 2u because it's 3u minus u. Okay, so from this we'll find the value of u. So I'll do 125 times 2 upon 10 equals 5u, and then from here I'll find the value of u. So 125 times 2 divided by 10, then again divided by 5 gives us 5. So u is equals to 5. Find the acceleration in the first u seconds. So this acceleration, which is simply rise over run. So for part B, find rise, which is 10, the run is u, which is 2. So acceleration is 2 meters per second square. Next question. A container ship, blah 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 blah. Never mind, let's just directly go to the point. Calculate the total distance traveled by the ship. Total distance is area under the graph. So I will break this into, what do I break this into? A trapezium here. Yes, a trapezium here. So this is the first trapezium. I should have read the question because I need this information. This is 9. So I need to know that this is 9. and then another trapezium. So here is another trapezium. So now I'll find areas of both these trapezium and add them. So for part A, the upper area is half times height. Height is from 9 till 14, so that's 5 units, times sum of parallel side. The lower side is, how do I know that? Again, I need to read the data for that. So what is this? Let's see. For 8 hours, and then it slows down over a period of 30 minutes. So this is 8:30. This is 8.5 hours. So this length is 8.5 and the upper length is 8. So the lengths of parallel sides are 8 and 8.5. Similarly, for the red trapezium, I'll do the same. Half times, what's the height? Height is still 9, times sum of parallel sides. So one side is for another 4 hours. It travels at this speed for another 4 hours. So after this, another 4 hours, that would be 12.5. So this length here is 12.5. So that's 12.5. So the upper parallel length is 12.5, this length, and the lower one is 13. So it's not so bad to read the whole question before jumping to the solution. Plus 13, the lower parallel length is 13. Find this product and you should get 12 kilometers as the final answer. No, not 12. It should be 156. Why did I write 12? I was just looking at the answer of part B. This should be 156 kilometers. Okay, then average speed for part B is total distance, which is 156 kilometer, upon total time. Time is 13 hours. What is the answer? 156 divided by 13. That's 12 kilometer per hour, the average speed. Okay, I've skipped a few questions in the worksheet because they were honestly so monotonous. Okay, question number 22 is slightly different, so let's go over it. A train journey takes 1 hour. The diagram shows the speed time graph of this journey. Calculate the total distance of this journey. Total distance is simply area under the graph. There's no unit conflict. This is kilometers per meter and minute, and this is also in minutes. So for part A, simply find area under the graph. Half times height times sum of parallel sides. The upper parallel side is 46. So what is the answer? 0.5 times 3 times 60 plus 46, which gives 159 kilometers. Okay, give your answer in kilometers. So that's already in kilometers. Part B, 1, convert 3 kilometers per minute into meters per second. Okay, let's do this. 3 kilometers per minute means upon 1 minute. Change this into meters per second. So to change this into meters per second, this will have to be multiplied with 1000, and the denominator will have to be multiplied with, what are we changing into? Kilometers per minute into meters per second. So this will be times 60. So we get 3000 upon 60. What do we get? 3000 upon 60. We get 50 meters per second. Okay, part 2, calculate the acceleration of the train during the first 4 minutes. Okay, so acceleration is rise over run. So it is going to be 3 upon 4. So 3 upon 4, the unit will be kilometers per minute square. Now the question says, wait a second, kilometers per minute square. Okay, the question says give your answer in meters per second square. Okay, so change this into meters, so times 1000. change the meter squares into second square, so we'll have to multiply it with 60 square because of the square unit. Okay, so now what's 3000 whole divided by, in the denominator, 4 times 60 square? This is giving me 5 upon 24, which is giving me 0.208 rounded off answer. 0.208 kilometers per second square. That's the answer. Meters per second square. Second square. Okay, question number 24, which is a tram leaves the station and accelerates for 2 minutes until it reaches a speed of 12 meters per second. It continues at this speed for 1 minute. It then decelerates for 3 minutes until it stops at the next station. The diagram shows the speed time graph of this journey. Calculate the distance in meters between the two stations. Okay, the first thing we should notice in this question is that there is a unit conflict. Okay, the next question, the diagram shows information about the journey of a train between two stations. Work out the acceleration of the train during the first 4 minutes of this journey. Give your answer in kilometers per hour. Give your answer in kilometers per hour square. Okay, so we have to find the acceleration in the first 4 minutes, which means slope of this, but there's a unit conflict in the question. This is in kilometers per hour and this is in minutes. So be careful about that. So when I find the slope, which is rise over run, the rise is 126 kilometer per hour, then the run needs to be in hours as well. So this is 4 minutes. So instead of writing 4 in the denominator, I will write 4 divided by 60. So enter this in your calculator. 126 divided by, press the fraction key, 126 in the denominator and in the numerator, 126 in the numerator and 4 divided by 60 in the denominator. I am getting 1890 kilometer as the final answer. Part B, calculate the distance in kilometers between the two stations. So now I need area under the graph. Again, I have to be careful about the units. So area of trapezium is half times height is 126 kilometers per hour times sum of parallel sides. So now the sum of parallel side needs to be in hours as well. So this is 55 minutes, which makes 55 upon 60 hours. And this is 44 minutes, 0948 till 090, excuse me, 0904 till 0948. So that is 44 minutes. So I will do 44 divided by 60. So I'll be adding these values, 55 upon 60 plus 44 upon 60. And this product should give me 103.95 kilometers. Okay, in the next question, the diagram shows the speed time graph for 60 seconds of a car journey. Change 90 km per hour to meters per second. Okay, so for that, we have 90 kilometers per hour means per 1 hour. We have to change kilometers into meters, so that means we're multiplying it with 1000. And then we're changing hours to seconds, that means we're multiplying it with 3600. So what does this give us? Numerator 90 times 1000, denominator 1 times 3600, which is giving 25 meters per second. Part B, find the deceleration of the car in meters per second. Deceleration is the slope of the falling line. There's a unit conflict. Remember, this is in kilometers per hour and this is in seconds, but we've already changed 90 kilometers per hour to 25 meters per second. So the unit conflict has already been resolved. So for part B, we'll use slope is equals to rise, which is 25, upon run, which is 60. So 25 upon 60 gives us sorry, it wasn't upon 60. It's supposed to be upon 20 because the run is 20. So this is 20. So 25 upon 20 gives us 1.25 meters per second square. Part C, find the distance traveled in meters in 60 seconds. So for that we find area under the curve. So half times height is 25 meters, times sum of parallel sides, so the lower length is 60 and the upper parallel length is 40. So find this product. This should be 1250 kilometers. Next question. The diagram shows the speed time graph for a part of a journey for two people, a runner and a walker. Calculate the acceleration of the runner for the first 3 seconds. So this line represents the acceleration of the runner for the first 3 seconds. So all we need to do is find the slope, which is rise over run. So rise is 3 minus 1.2, which would be 1.8 upon run, which is 3. So 1.8 upon 3 gives us 0.6 meters per second square. Part B, calculate the total distance traveled by the runner in the 19 seconds. So now we'll be finding area under the graph for the runner. So that's the area of this shape. So we have a trapezium and underneath that we have a rectangle. So we will be finding these two areas and adding them. So half times what is the height of the trapezium? It's 1.8 times sum of parallel sides, that's going to be 19 plus 3 till 15, that's 12, plus area of the rectangle, which is 1.2 times 19, which gives 50.7 meters. Part C, the runner and the walker are traveling in the same direction along the same path. When time is equals to 0, the runner is 10 meters behind the walker. Find how far the runner is ahead of the walker when time is equals to 19. Okay, so for part C, we first have to find the area or the distance covered by the walker, which is the area under this rectangle, which we've already found in part B. So that was 1.2 times 19. What does this give us? 1.2 times 19 gives us 22.8. So this is the distance covered by the walker. And what's the total distance covered by the runner? That's 50.7. So we subtract these two values. 50.7 minus 22.8, and also at the start of the time, when time is equals to 0, the runner is 10 meters behind the walker. So we'll have to adjust that as well. So this gives 50.7 minus 22.8 gives 27.9. And then we also have to subtract a 10 from the answer to make adjustments for this, because the walker was 10 meters behind initially. So we subtract 10 from the answer and we get 17.9 as the final answer. The diagram shows speed time graph of a bus journey between two bus stops. Hamid runs at a constant speed of 4 meters per second along the bus route. So Hamid's speed time graph would look something like this. This is 4 meters per second. He passes the bus as it leaves the first bus stop. The bus arrives at the second bus stop after 60 seconds. How many meters from the bus is Hamid at this time? So this question is simply asking us to find the area of the triangle, which will give us the distance covered by the bus in 60 seconds. Then find the area of the rectangle, which will give us the distance covered by Hamid in 60 seconds. And the question is asking for the difference in these distances. So that's what we do. We first find area of the triangle, half times base times height, and then subtract 4 times 60 from it. This should give 180 meters. Next question. The speed time graph shows information about a train's journey. By drawing a suitable tangent to the graph, estimate the gradient of the curve at time is equals to 24. So where is time 24? Here. So we will be making a tangent over here at time is equals to 24. So that's going to be roughly, very roughly this line. It's not a very good tangent. Let me try one more time. Oh, that's even worse. Final attempt, and then I'll just go with what I got. Okay, here it is. So this is the tangent. So I already have 1 point here. That's 24 comma what's the value over here? 24 comma 1.3, and then I'll take a point on the x-axis. This is, let's say, 26, 27, 27.5 comma 0. So now I'll find the slope using these 2 points. y2 minus y1 over x2 minus x1. So what am I getting? 1.3 divided by 24 minus 27.5, which is, I'm getting minus 0.2, which is nowhere close the range given in marking scheme, but my tangent was very rough. I did not obviously use any scale. So with the proper scale and by reading proper points, you should get a value in between this range. So do that yourself. Part B, what does this gradient represent? Gradient in a speed time graph represents acceleration or deceleration. Since it's a falling line and since we got a negative answer, the answer should be, exact answer should be the deceleration. Okay, part C, work out the distance traveled by the train when it is traveling at a constant speed. So it's traveling at a constant speed from here till here. So we need to find area under this graph. So that's this length. Yes, this length here till this length here. So find the number of units between these lines and find the area of this rectangle. So now what's the height? Height is 4 units. So height is 4 for part C. We do 4 times what is this? So what is this length? Okay, so this is 5, 10, 15, and then 2 small boxes is 1 unit. So 15, 16, 17. So this length is 17. So then we do 4 times 17, which gives us 68, which is the answer. The distance time graph shows the journey of a train. Find the speed of the train between 7 to 7:30. Give your answer in kilometers per minute. So in a distance time graph, speed is the slope. So we need the slope for this in kilometers per minute. So the rise is 50 kilometers and the run should be in minutes. So that's 30 minutes, which gives us 5/3. Oh, sorry, I just spotted a mistake in the question that I copied from the past papers. This is in hours. So we need to change the 30 minutes in the denominator into hours. So we divide it with 60 and this would give us 100 as the final answer. Divided by 60, enter this whole fraction into the calculator, we will get 100, which is the correct answer for part 1. Part 2, find the average speed for the whole journey, give your answer in kilometers per hour. So for average speed, we'll have to find total distance upon total time. Total distance is 200 kilometers from the y-axis upon total time in hours. So from 7 to 9:10 we have 7, 8, 9, 2 hours 10 minutes. Change 2 hours and 10 minutes into hours. So what do we get? 10 divided by 60 plus 2, we get a fraction 13 upon 6. Solve this. 200 divided by 13 upon 6, which gives 92.3 hours, rounded off answer. Sorry, kilometers. Yes, kilometers per hour, not hours. So this is, the unit is kilometers per hour. Kilometers per hour. Okay. Part B. The speed time graph shows the first 30 minutes of another train journey. The distance traveled is 100 kilometers. The maximum speed of the train is v kilometers per hour. Find the value of v. So we already have the distance, which is 100 kilometers. Distance is equals to area under the graph, and this shape is a trapezium. So half times height, which is v, times sum of parallel sides, which should be in hours, since the y-axis is in kilometers per hour. So 6 to 6:30 is half an hour, so 0.5 plus we have 5 till 25 minutes. So that's 20 minutes, which makes 20 upon 60, which makes 1 upon 3. So this would be 1 upon 3. So now make v the subject from here. So we get 200 equals v times, what is 0.5 times 1 upon 3. We get 1 upon 6. Solve this and we get 200 times 6. Sorry, this would be 5 upon 6. So now 200 times 6 divided by 5 is equals to v, which is 240. So v comes out to be 240. Part 2, find the acceleration of the train during the first 5 minutes. Give your answer in meters per second square. So we need the acceleration. Acceleration is the rise over run, which is the slope. And be careful about the units required. That's meters per second square. So v came out to be in kilometers per hour. Let's change this into meters per second. We actually need the rise over run, so rise would be 240 kilometers per hour. And what is our run? Run is simply 5 minutes. But the answer should be in meters per second square. So first I'll change the numerator into the correct units. So 240 kilometers over 1 hour. Change this into meters per second. So I'll multiply the numerator with 1000 and multiply the denominator with 3600. So that gives 240 times 1000 divided by 3600. So the numerator becomes 200 upon 3. So the numerator is 200 upon 3 meters per second, divided by the denominator should be in seconds as well. So I'll simply multiply 5 with 60 over here. 5 times 60 gives 300. So now divide these. 200 divided by 3 whole divided by 300, which is giving me 2 upon 9, which is the correct answer. The final answer should be 2 upon 9, which is the correct answer according to the marking scheme. Next question. The diagram shows the distance time graph for the first 65 minutes of a bicycle journey. Part A. There are 4 different parts to the journey labeled A, B, C and D. Write down the part of the journey with the fastest speed. So fastest speed would mean the greatest slope. So know that a horizontal line has a 0 slope and a vertical line has the maximum undefined slope. So for a line to have the steepest slope, it needs to have, for a line to have the largest slope, it needs to be as close to a vertical line. For example, this purple line will have a slope bigger than this blue line, because the steeper the slope, the bigger its value. So which one of these slopes, A, B, D, is the steepest? So line A has the steepest slope, so the answer for part A is simply line A. Part B. After the first 65 minutes, which is here, the bicycles traveled at a constant speed of 20 kilometers per hour for 15 minutes. Okay, draw this part of the journey on the diagram. Okay, so 20 kilometers per hour would simply mean how many kilometers in 15 minutes. So in 15 minutes, that would mean 20 kilometers divided by 4. So that would make 4 kilometers in 15 minutes. So we have to plot 4 kilometers per 15 minutes. That means we need to make a slope 4 kilometers rise and 15 minutes run. So this is 15 minutes, 5, another 5, another 5, and then go 4 kilometers up. So 1, 2, 3, 4. So we land 1, 2, 3, 4. We land over here. Oh, sorry, we were supposed to divide 20 with 4, which gives us 5. Because 1 hour divided by 4 is 15 minutes. So 20 divided by 4 is 5 kilometers. So it's 5 kilometers rise and 15 minutes run. So 15 minutes means 3 boxes ahead, and 5 kilometers means 5 boxes up. So this is the point. So we make a line from here till here, a straight line from here till here. Okay, Ali leaves home at 1000 to cycle to his grandmother's house. He arrives at 1300. So that's time. That's 10 o'clock and then that's 1 o'clock. The distance time graph represents his journey. Part A. Calculate Ali's speed between 10 to 11:30. Give your answer in kilometers per hour. So speed is the rise over run. So we need the rise over run from here of this line. So the rise is, what is this? Is this 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, that's 12. So the rise is 12 kilometers. And what's the run? The run is this. Now what's the value over here? We have an hour over here, 1 hour over here, and then this would be 1, 2, 3, 4, 5. So it's an hour and a half. So we need to give the answer in kilometers per hour. So 12 is in kilometers and this should be in hours. So 1.5. So M is equals to 12 upon 1.5. What do we get? 12 divided by 1.5, we get 8. So speed is 8 kilometers per hour. 8 kilometers per hour. Part B. Show that Ali's average speed for the whole journey to his grandmother's house is 12 kilometers per hour. Okay. So the average speed is total distance upon total time. So the total distance is this much. And what is this value? this would be 30, 31, 32, 33, 34, 35, 36 kilometers. So the total distance is 36 kilometers. Upon total time was 10 till 1, so that's 1, 2, 3 hours. So 36 divided by 3 gives us 12 kilometers per hour. Oh. Part C, change 12 kilometers per hour into meters per minute. Okay, so we have 12 kilometers per 1 hour. Change this into meters per minute, so we multiply this with 1000 and multiply the hours with 60. So I'll enter this thing in my calculator. In the numerator, 12 times 1000 divided by 60, which is giving me 200. So I'm getting 200 meters per minute. Okay. Then it says Ali stays for 45 minutes at his grandmother's house and then returns home. He arrives home at 1642. Complete the distance time graph. Okay. So let's read that again. Ali stays for 45 minutes at his grandmother's house. So we need to make a straight line for 45 minutes and then we'll join that straight line with 1642. Okay. So how do I make a 45 minutes line over here? Okay. So each small box on the x-axis is actually 6 minutes. So that 10 boxes are making 1 hour. So how many boxes of 6 units do I need to get to 45? So I'll do 45 divided by 6, which gives me 7.5. That means I need to make a vertical line over here horizontal line covering 7.5 boxes. So 3, 4, 5, 6, 7 and 7.5. So this is 45 minutes. And now join it with 1642. So there's 1642 again. How many boxes would cover 42 minutes after 1600? So 42 divided by 6 is 7. So go 7 boxes ahead. 1, 2, 3, 4, 5, 6, 7. Here's 1642. Join these with a straight line and you have your answer.